Hey, welcome to the last video of Unit 6. This is Lesson 5. I know it says Day 7 up on the top. It's just the 7th day that we've been working on this stuff. But today we're going to evaluate and approximate square roots, and we're going to solve quadratic equations by taking the square root of both sides. So today we're going to solve equations that have equal sign in them to find values of x that make the equation true. And our essential question today is, how do I solve equations with exponents and radicals? So let's review how to solve equations in general for x. Well, I'd follow the order of operations first to simplify. I do whatever in parentheses first. Can I combine the 3x and the 1? No. So I cannot do parentheses. Are there any exponents? I don't see any yet. So I'll go past that stage. We're going to go to multiplication and division left to right at the same time. If I go left to right, the only multiplication or division I see is this multiplying the 2 rather than negative 2. By the 3x and the positive 1. So I have 5x minus 6x, and the negative 2 times positive 1 is negative 2. Now it'll equal 14. So I've done the multiplication division left to right. Now I do adding and subtracting left to right. Okay, I go ahead and do the operations as I see them. Negative x, 5 minus 6 is negative 1x, minus 2 equals 14. I'll add 2 to both sides. Then I get negative 1x, or negative x, equals positive 16. If I divide by negative 1 now, what does x equal? Negative 16. And now what this is the value of x. If I plug that in up here for x, I should get an equation that's true. Up here and up here in both spots. That's 80, negative 80 minus, and this should be, looks like, well, I'll skip that for now. You can figure it out later. Mental math wasn't as good. Let's subtract 4 from both sides here. All right. 5 over 4 times x equals negative 7. Now I'll multiply by the reciprocal, or in other words, I'm going to multiply by 4 over 5. Multiply this one by 4 over 5. When I do that, I get 20 over 20 times x. That's just going to be 1x. On the left side, this is a fraction. Negative 7 over 1 times 4 over 5. I get negative 28 over 5. X equals negative 28 over 5. That would be my answer. Okay. Remember that a square root or second root answers the question, what number multiplied by itself will give me the radicand? Remember, the radicand is the number inside of the radical. Since this is a square root, I want to know what number times itself will get me 16. Of course, that is 4 times 4 would give me 16. So therefore, the square root of 16 ends up being 4. So find the square roots of the following numbers. In other words, find the value of each variable. So if the square root of 49 equals x, both sides of this equation have to be equal. The square root of 49 will end up being 7, because 49 is 7 squared. And then I will undo that second power with a second index radical. So 7 equals x. How about this one? Well, the square root of 0, 1 times itself will give me 0. Of course, 0 times 0 is still 0, so the square root of 0 is 0. Now, what number multiplied by itself will give me negative 4? You might be thinking negative 2, negative 2 times negative 2. Does that work? No, it doesn't. Negative 2 times negative 2 is positive 4. What about 2 times 2? Nope, that can't be it. Negative 2 times positive 2, well, those aren't the same number. There actually is no solution. There's no number, c, that will be the square root of negative 4. And in fact, for any negative number, there can then be no solution. If I had negative 9, that's not going to be negative 3, because negative 3 times itself is a positive 9. The square root of any real number that is negative does not exist, at least not in the real number system. Let's practice evaluating expressions for values of variables. A is 2, B is 4. If I write this in here, I will have 3 plus, and what is b? B is 4, so I'm going to substitute in that for b, plus 12 over 7 times whatever my a value is, and my a value in this case is 2. And all I have to do is simplify. I'm using the order of operations, PEMDAS. Now I do parentheses. Is anything in parentheses? That's 2. Can't do anything inside of there. We're done with parentheses. Any exponents? Now technically, a square root is an exponent, but we won't talk about that in this class. We have to do things inside the radical first. 4 plus 2, okay, or sorry, 12. 4 plus 12. So 3 plus the square root of 16 over 14. So I kind of did some multiplication there too, but the e is actually taking the square root of 16. That's an exponent. So 3 plus the square root of 16 is 4 over 14. We get 7 over 14, which simplifies into being 1 out of 2. So again, the exponents, anything, a radical is an exponent. So we do radicals during the exponent stage. Radicals will happen during the exponent stage when we do PEMDAS. Let's look at the other one over here. We have the square root of b squared. What's b? B should be 4 in this example, plus 10 times a, which is 2. So do the order of operations. We're going to go parentheses inside the radical first. Okay, no exponents. Square root of 4 squared is 16, plus 2 times 10 is 20. We're going to add those together. Square root of 36. Still on the P and E stage, we haven't done any multiplication, division, adding, subtracting left to right. Square root of 36, though, is 6. All right, now we've come to the part that is new, all right, the part that we did not know how to do until right now. Let's say that I want to know what number squared is 49. Well, of course, the first answer you know for sure is 7. However, there's another answer that we haven't mentioned, -7. To solve this equation for x, I need to undo or use an inverse operation for the exponent 2. And the inverse operation for an exponent is the radical that has the same index. So this second radical, or square root, will cancel out the squared on the x. Those two operations are inverse here. Now, I took the square root of 49. I'm asking what number times itself twice will give me 49. And of course, 7 times 7 will, but so will -7 times -7. That will also give me 49. Both of these numbers, 7 and -7, would be my answer. So my answer would be x equals 7 or x equals -7. Another way to write this would be x equals plus or minus 7. I prefer that you write it as two different answers because I want you to emphasize there are two numbers that satisfy this equation for x. You can put in 7 for x, or you can put in -7 for x. On the other side, the way we solve equations that have exponents in them, I want to get the term or the variable with the exponent by itself first. So I will begin by subtracting 3 from both sides. 64 is now equal to x to the second power. And I'm asking myself again, what values of x will make this equation true? Well, then I would have to take the second root to undo the second exponent on the x squared then. So I'd have x now is equal to, and what number will satisfy this condition, the square root of 64? What number multiplied by itself will give me 64? Well, 8 will, and so will -8 times -8. So my answer will be x equals 8 or -8. All right. How about this one? I solve by getting the variable by itself. I'll add 25 to both sides. I get 9x squared equals 25. Variable by itself, by 9. I'm working the outside in here. So we get x squared equals 25 divided by 9. Now we need to take the square root of both sides to solve for x. I want to get the second variable away, sorry, the second exponent with the second root to go away. X equals, now I'm going to have the square root of 25 divided by the square root of 9. Now, since I took the square root of myself, I don't know whether it's going to be positive or negative. So x will be equal to the positive 5 over 3, or x equals negative 5 over 3. So when I solved there, I kind of didn't explain that as much as maybe I should have. The reason I get a positive or negative value is because I don't know which radical or which square root I will be taking. Because the square root of 25 is two possible values for x to make it true. It can either be 5 or negative 5. And 9, the square root of 9, has either 3 or negative 3. So it could be any combination of plus or minus 5 over plus or minus 3. You could have them both be positive, which would be a positive 5 over 3. They both be negative, which would be another positive 5 over 3. One could be negative and one could be positive, and that gets me the other possible answer. On the right side here, if I subtract 6, I get 2x squared equals 0. If I divide by 2 now, 0 divided by 2 is still 0. Everything I'm doing now is sort of unnecessary. You should realize right away, if I have a number squared to equal 0, that number has to be 0. Now notice there's no plus or minus 0. It's not a positive or a negative number. 0 is the one real number that has no sign. How about this one? Minus 8. Minus 8. 2x squared equals negative 8. I divide by 2. And I get x squared equals negative 4. If I take the square root of both sides, you should notice there's a problem. The left side is fine, I get x, but I want the square root of a negative 4. What number times itself will give me a negative 4? There's no real number that will make that true. You have to write no real solution for this one. I didn't mention that last time, but you will have to say no real solution. There's something called an imaginary number. There's an imaginary number called I, which ends up being the square root of negative 1, but we don't do that until algebra 2. Look at this one, negative 16t squared plus 100, and I want to know what t is. So then I subtract 100 from both sides. Negative 100 equals negative 16t squared. I solve by dividing by negative 16. Notice I didn't just end the problem when I saw negatives on the other side, because when I divide by the negative 16, I get 100 over 16. And I'm not even going to simplify the fraction, because now my final step to solve for t is to take the square root of 100 over 16 and the square root of t squared. So on the right side I get t, and on the left side I get positive or negative square root of 100 over the square root of 16. Of course, that's going to be positive negative 10 over 4. Is t. So t either equals 5 halves, or I reduce the fraction, negative 5 out of 2. And that's what negative 10 over 4 is reduced. Where do I use this in the real world? Let's say I had a tragic accident while eating around this guy's pizza. I tragically dropped a slice of pizza off the side of the roof deck. The roof deck is about 32 feet off the ground. So here I am at the top of the building, unfortunately dropping a delicious pizza slice down straight towards death on the concrete here. And let's say that the height of the building is 32 feet off the ground. Well, this equation, height, is equal to negative 16 t squared, where t is time. The negative 16 is gravity, pulling it down. And s is the starting height. Let's calculate how much time it's going to take for that to hit the ground. The h in this equation is the height of the object. And what do I want the height of the object to be off the ground? Height off of the ground. If it's on the ground, what's the height? My pizza is smashed on the ground. The height h will be 0, and that should be equal to negative 16, which is the force according to gravity, negative 16 feet per second squared, multiplied by t squared, which is time squared, plus the initial height, which I started at 32 feet above the ground. Okay? Subtract 32. I get negative 32 equals negative 16 t squared. I divide by negative 16, t squared equals 2. Then I take the square root of both sides. I get plus or minus the square root of 2. So it takes the square root of 2 seconds. Have a good night.